The latest data from the James Webb Space Telescope is sending shockwaves through the scientific community. For the first time, we've captured an incredibly clear view of the massive eruption of Betelgeuse, the red supergiant star. It's ejecting colossal amounts of material into space, some of which may eventually reach Earth. Explosions of this scale are rare, especially so close to our own solar system. This extraordinary event offers a deeper understanding of the intense and chaotic forces that unfold during the final phases of a star's life. It also highlights the immense cosmic cycles that govern our universe. Supernovae serve as quiet but powerful evidence of the universe's most violent phenomena. Everything we know and everything we are has been forged from the remnants of stars that died long ago. When the first massive stars ended their lives, they seeded the universe with new elements, and possibly even created the first carbon-based compounds that would one day lead to life. Betelgeuse's explosion will release fresh material into the cosmos, and some of it might eventually become part of our own world. Tiny particles like neutrinos will reach Earth, subtly altering our planet's fabric. As Betelgeuse meets its fate, immense clouds of stellar dust and debris will begin a vast journey across the galaxy. And with Betelgeuse only about 600 light-years away, a mere hop in cosmic terms, we're in a front-row seat to witness how this supernova may directly influence us. It's the closing chapter of a stellar giant, the supernova of Betelgeuse. Betelgeuse, a red supergiant located in the constellation Orion, is also known to many astronomy enthusiasts as Alpha Orionis. It's one of the most recognizable stars in the night sky. Positioned roughly 430 to 724 light-years away, it ranks among our closest stellar neighbors and is easily visible to the naked eye. For millennia, this brilliant red star has illuminated Orion's shoulder, capturing human imagination. Alpha Orionis isn't just bright, it's massive. Its radius is about 764 times that of our Sun, large enough to engulf the orbits of Mercury and Jupiter if it were placed in our solar system. Historically, sailors, ancient astronomers, and entire civilizations saw it as a blazing celestial fire, an omen or a message from the gods. Today, we understand that Betelgeuse is nearing the end of its life. When it finally dies, it will explode as a supernova, violently scattering its material into space. Any nearby planets or stars would be obliterated instantly. However, Betelgeuse likely devoured any planetary companions long ago. If it had a stellar partner, that companion may have perished or merged with it. Interestingly, there have been theories suggesting that Betelgeuse was once part of a binary star system, similar to Alpha Centauri, one of our closest neighbors. Simulations struggled to explain the star's immense size, until one theory proposed a simple solution: Betelgeuse's colossal scale might result from two stars merging into one massive supergiant. This suggests that binary stars can evolve into a single, enormous red giant at the twilight of their existence. Stars nearing the end of their life cycles are especially fascinating to scientists, as they reveal the dramatic processes that ultimately lead to the birth of new celestial bodies. Thanks to the powerful capabilities of the James Webb Space Telescope, many of these mysteries are now coming to light. Naturally, one of the most compelling targets for observation is the supernova candidate Betelgeuse. The James Webb Space Telescope, or JWST, observes the universe in the infrared spectrum, giving it a unique advantage. It can penetrate the outer layers of red supergiant stars like Betelgeuse, offering an unprecedented look into their inner structure. Between late 2019 and early 2020, Betelgeuse underwent a surprising dimming event that caught the attention of astronomers around the world. Its brightness dropped significantly, from a magnitude of 0.5 to 1.7, a change visible even to the naked eye. This unexpected darkening initially caused widespread speculation, but researchers eventually traced the cause to a massive surface mass ejection, similar in nature to an extremely powerful solar storm. While solar ejections are normal for our Sun, Betelgeuse experienced an outburst 400 billion times more powerful than a typical solar event. This massive ejection led to the formation of thick dust clouds from the expelled material, which shrouded the star and caused it to dim dramatically. Observations from Hubble and ground-based telescopes revealed enormous gas clouds and multiple layers of dust and debris forming a shell around the star. Even after Betelgeuse became mostly visible again, fluctuations in brightness persisted, along with the appearance of star spots, cooler regions on its surface. This ongoing activity sparked debate. Was the dramatic dimming a normal phase in the star's life, or a warning sign of its impending collapse? To get clarity, astronomers turned to the James Webb Space Telescope, JWST. For the first time, they were able to peer into the inner workings of Betelgeuse. Picture the star as a vast, puffed-up, slightly porous mass of hot gases. Its outer layers are already unstable, allowing JWST to see deeper with ease. Since Betelgeuse emits most of its light in the infrared spectrum, JWST, designed to detect infrared radiation, was ideal for cutting through the surrounding dust and gas. It gave astronomers an X-ray-like view of the star's internal activity. They discovered turbulent convection currents, much like those found deep within our Sun, now clearly visible inside this fascinating and volatile giant. These stellar currents create distortions, dents, bulges, and temperature variations across the star's surface. In the outer layers, clouds of gas and dust begin to form. When fragments of the star's surface break away, they can release vast amounts of material, much like what we observe with our own Sunday. Thanks to the James Webb Telescope's real-time imaging of energy and dust distribution, scientists now have something akin to a dynamic map of the star. These observations offer valuable insights into deeper internal processes, allowing researchers to understand, for the first time, the full life cycle leading to a supernova. Currently, nuclear fusion within the star is transforming helium into heavier elements like carbon, neon, and iron. These elements weigh the star down, slowing its activity. Some scientists have even likened the noticeable dimming of Betelgeuse in 2019 and 2020 to the weary cough of an aging giant nearing the end of its life. When the core eventually begins fusing only iron, energy production will cease. That moment will trigger the collapse, leading to a violent supernova that rips the star into billions of fragments. The intense heat from the explosion will consume most of the remaining matter, releasing mainly gas and dust into space. So, what happens on the fateful day Betelgeuse dies? The build-up to its end will be marked by rising internal pressure and a dramatic increase in brightness. From Earth, Betelgeuse will outshine every other star in the night sky. This brilliance results from a final series of chemical reactions and fuel burns before fusion ultimately fails. The star will implode, and then explode under the force of its own gravity. The resulting flash will be up to 1,000 times brighter than our Sun, lighting up the galaxy for weeks. The light will shine as brightly as a full moon in the night sky. While this celestial event is both awe-inspiring and relatively close, it poses no danger to us on Earth. Naturally, the arrival of this Day X is being eagerly anticipated around the globe. After all, supernovae are rare phenomena. The earliest recorded supernovae visible from Earth occurred in the years 1006 and 1054 AD. These explosions were observed by astronomers in China, Japan, and Persia, as well as by various indigenous cultures. Witnesses described a brilliant light in the sky that remained visible for weeks or even months. More recently, in 1987, a supernova exploded in the Large Magellanic Cloud, a neighboring galaxy just 170,000 light-years away. The dying star, named Sanjalik-69°202a, was a blue supergiant about 17 times the size of our Sun. Its final burst of light was so bright that it could be seen with the naked eye from Earth for a short time. This marked the last supernova visible without telescopes or other instruments. Now, all eyes are turning to Betelgeuse. Its eventual explosion will be a spectacular and unforgettable sight. When it happens, it could appear as a second moon in our night sky, visible for several weeks. Billions of people will witness this extraordinary event. There is no need to worry about Earth being struck by debris. Most of the star's matter will be pulverized in the explosion. The remaining dust and gas will spread through the nearby region of space, drifting along the currents of our galaxy.